I was completely lost in the stars. I couldn't find my own way. And that experience, I thought was going to top everything, except for just a few moments later, I looked down at my feet and I saw my own shadow because of the starlight and the Milky Way.
Yeah.
And to have a place that is that dark is not necessary to see the Milky Way, but it's the best way to see the Milky Way. Welcome to the Cosmos Safari podcast. I'm your host, Dave Farina. And in this podcast, we're going to be talking all about the best things to see in the night sky.
I'm getting excited about this one, of course, because we love astronomy, right? We're going outside. I'm looking forward to talking about the Milky Way, the moon, the planets, some globular clusters and nebulae and galaxies. But before we do that, Dave, are you ready for some trivia?
Let's do it.
Fantastic. Let's get started here. Okay. First one. I think you're going to do well on this one. Let's see. Let's see if our audience is good here too. Which planets can we see with our naked eye?
Okay, that's one that I really like because the first thing that you might see, the brightest one, of course, is the planet Venus. And Venus is, in the morning and in the night. Generally, you think about that. And of course, you also have Mercury as well. And then from there, you've got Mars, Jupiter, and Saturn. And then the other planets were not discovered until we had telescopes.
Right. Very good. Ding, ding, ding. You missed one, though. What other planet can you see with your naked eye?
Earth.
Yes. Very good. Very good.
Yes.
Just look down. I always love the fact when I'm talking with the public, I love the fact that the word planet comes from planetes or something in Greek, which is wanderer in the night sky, right? Because they're the only points of light other than the sun and the moon, the only points of light that actually wander throughout the constellations, right?
Right.
It was just unique. If you think about it, there are only 5 things out there that don't move the same as everything else, which is pretty cool.
And then, of course, the moon and sun, all of which, of course, had their own special places within, ancient mythology. They were seen as this special thing in the night sky, but they were also used as a way to kind of tell the tales and understand the world around them. So that oral tradition and the ability to tell those stories and pass the knowledge down to the young ones was key, and the planets helped to tell that story.
Yes. Now, one of the other things that affect the first one that I mentioned. So here is trivia question 2. When was the first scientific drawing of the Milky Way drawn? Bonus points if you say who. Now, while you're thinking, I'll say I was looking stuff up, and I know that there are like Aboriginal, Native American drawings and such of the Milky Way. So I don't want to discount that, but I didn't go down that rabbit hole. So I'm wondering, when was the first scientific drawing of the Milky Way?
Now, I'm going to say it's got to predate the telescope. The Rudolphian tables, I believe, were the last of the non-telescopic mapping of the night sky. That would be Tycho Brahe. So I'm stuck on this one. I don't know.
You're stuck? Now, assuming I did my research well, I have the first attempt to describe the shape of the Milky Way and position of the sun within it was carried out by William Herschel in 1785.
Right, the disc shaped. I guess that was like a loaded question. I was thinking more along the lines of the Milky Way in the sky, but you're talking about the Milky Way as a galaxy.
Yeah, my research was short on this one, so perhaps I should go in and dig a little deeper, because there probably were some sketches of what it looked like in the sky, and I just looked up those Rudolphine tables. Didn't get to read anything, but I looked them up. We'll have to, you know what? I'll come back to this one and see if we have an update next time. But yeah, it was. Then in 1785, he carefully counted the number of stars in the different regions of the visible sky and produced a diagram. And it kind of looks like a spider web to me, actually.
Right.
It's kind of interesting there. But yeah, and the first one to actually show that it was multiple stars and not like one thing, that was Galileo. You were pretty much right on the button there, because he looked through his telescope and he's like, oh, that's actually just a bunch of little stars, or a lot of stars put together. Sure. What is the best way to make sure that clouds interrupt your observing? Is it A, get a new telescope delivered to your house, or B, make any sort of plan to go outside at night?
Well, I can attest to A, that sometimes, it does feel like you get a new piece of gear, you really want to use it, and of course the clouds get in the way. That actually happened to me recently, so I'm going to go with A. But B's a close second, especially if you have to drive really far.
Yes.
then it'll tempt you. It'll be kind of on the edge. It won't quite tell you that it's going to be clouded out. It'll say, partly cloudy possible, or completely clear. Right?
Yeah. Exactly.
That sounds like every trip I've ever taken up to Cherry Springs, our dark sky site here in Pennsylvania.
You're rolling the dice every single time.
Every time. Rob and Dave discuss how to observe the Milky Way as well as planets right after this short break.
Master the art of stargazing with SkyMaster Pro ED, Celestron's top-of-the-line astronomy binocular. Our engineers have perfected every detail so you can immerse yourself in the night sky. The same XLT optical coatings we use on our best telescopes combine with extra low dispersion ED glass to deliver unmatched low light performance. You can even add your favorite astronomy filters. Learn more at celestron.com/SkyMaster.
All right, so let's get into the night sky and what to look at, right? And I figured I would start off because I don't use telescopes quite as often as you do. So I wanted to get started real quick on something that anybody can see if they're in the right spot. And that's the Milky Way, right? That stretch of sky where it's just a little bit white. It looks like this like milkiness that sort of spreads across the sky. And what I found is that if you're going to see it, you have to have dark enough skies, right?
Of course.
Now, where we live, or actually where my school is in, if you look at the light pollution map, like the most common one that's online, we're in the yellow category. And only a couple of the nights where we've had star parties have we actually really been able to see the Milky Way. But we were able to see it. You just have to have a very clear night, meaning no clouds, but also meaning not much moisture either. Right.
Transparency.
Yeah. Like it could be a clear night, but if there's a lot of moisture or if the moon's up and it's hitting that moisture as well, you're not going to see the Milky Way. So just a little tip, like go out, but go out often and see if you can see it.
So an interesting thing about the Milky Way, and then the word galaxy, if you think about it, galactic, the lactic part of it would be like milk, right? So it's milk-like in its structure, and we are living within the Milky Way, one of the galaxies of the universe. So I always found that interesting.
I like that. Yeah.
Speaking of the Milky Way, I'm just kind of reflecting as you're talking about this. One of the first times that I was ever able to, get out and get to a dark sky site. Once again, our dark sky site here in Pennsylvania, the darkest place is in Cherry Springs State Park in Potter County, Pennsylvania. And my brother and I actually traveled up there my first year of teaching. So this would have been back in like 2008. And we were camping. And I got up in the middle of the night and I walked outside my tent and I looked up at the night sky and I was just blown away. The amount of stars that I was able to see was more than I've ever seen in my entire life. And although I run a planetarium, I was completely lost in the stars. I couldn't find my own way. And that experience I thought was going to top everything, except for just a few moments later, I looked down at my feet and I saw my own shadow because of the starlight and the Milky Way.
Yeah.
And to have a place that is that dark is not necessary to see the Milky Way, but it's the best way to see the Milky Way.
Yes, it is.
Absolutely. Just, you know, if I just thinking about it now, I get chills up my back, and it's amazing that these places still exist. And I really, really hope that all of our guests have an opportunity to get out and to get to one of these dark sky places at some point, because it's so moving. And especially if we can get little kids out there to see this while they're young and interested. I think it'll change, their perspective on their cosmos.
Yeah, I like to go, whenever I go on a trip anywhere else, I like to look at the light pollution maps online, and I like to see if there's anything close by, right, that might be somewhat darker skies that I can go to. Like you said, Cherry Springs in Pennsylvania. I've been to the Outer Banks, and there's a wildlife refuge, kind of like, I think it's in the middle somewhere. That was pretty good. Not the best, there's still light pollution from Nag's Head and stuff there, but at least there was this spot where I could get pretty decent shots of the Milky Way. And if you're traveling, just find those spots and just spend like one night that's clear, and guaranteed to be clear. Spend one night out there, and that brings me to my second part about the Milky Way, which is actually getting pictures of it.
Okay.
That's my favorite thing, which is using a DSLR camera. That's the way I do it. I know that phones are getting better, but as far as the Milky Way goes, it's still not as good as a DSLR in my opinion, for the Milky Way. But it is a very quick shot with your phone. I have, in fact, when we were up at Cherry Springs last time, I got a couple pictures of the Milky Way with my phone. I needed it on a tripod and such, but I could get pictures of it. But the DSLR does such a better job of taking those long exposures. And then you could kick it up a notch by having it actually track the motion of the Milky Way. And so you can get a longer exposure. And then you can go down Dave's route, which is the expensive, both in time and money, which is like stacking the photos together and actually like working in post-processing and that sort of thing, which can be really awesome, but I don't have the patience for that.
Let's just back this up a few seconds though. Most people have a phone, and I want to encourage people to try the phone, because it is actually pretty impressive what they're capable of. Now, as Rob said, you were going to definitely want to have a tripod of some sort. And Rob's, if you're watching this video, Rob's holding up a small tripod right now.
Yep. And get the little tripod with the phone adapter. It's nice.
Right. They're relatively inexpensive for the tripods. And what that will allow for is it will allow for that stability that's needed to keep, the phone still. What I would also suggest is use like a timer, or there's little remote controls you can get that will actually open the shutter for you. But you can always do like the countdown timer. That way you're not touching the phone when it's taking an image, because as soon as you touch the phone, it will shake it a little bit. And that shaking can make it difficult for the image to be processed properly by the phone.
I've got a function on mine that'll actually, all I have to do is say smile and it'll take the picture. So if you see a weirdo going out there in the middle of the night saying smile, smile, it might just be somebody taking pictures of the Milky Way.
Right. So the next thing is that, a lot of these modern phones are using internal stacking process. That is very similar to what we would be doing in the more high tech, as Rob was saying, astrophotography world. But it's done automatically for you. And so these 10, 15, 20, 30-second exposures are being taken by the phones, and then they're automatically aligned and stacked, which basically all that means is you're trying to increase the signal to noise ratio. So more of what is the Milky Way and the stars is visible, and less of the noise of the camera sensor. And it's pretty impressive, and it's only going to get better over time, right? So the camera sensors of today are light years ahead of where they were just a few years ago. And in another few years, they're going to be even better. And so I really encourage you to get out there, try it, and just try to do the best you can with the equipment that you have.
Yeah. Experiment. That's in fact, that's one of the reasons I loved the DSLR when I started doing this like 20 years ago, is it was a digital camera and I got like instant results right away, which was just, it was motivating because I could experiment and mess around. I didn't have to have film and wait a week to get it processed and all that. So it was pretty nice. Now, the Milky Way is great, but we have another object up there that is not always up in the sky, but at least that we can see, but it is really easy to find. What would you say is the easiest object to find up there?
Of course, the moon.
Exactly. So, in fact, I was just observing the moon the other night in the telescope that you lent me. And the really cool thing about finding the moon is, well, A, you don't actually need a telescope. Like, you can actually look at it and have fun observing it without a telescope. All right. In fact, one of the things I like to have my students do is actually track what the moon looks like every night for a month. And you start really getting a sense for how does the moon move throughout the month? How does the angle between the sun and the moon, how does that change what we're seeing? And it gives you a much better feel for how everything around you, those celestial mechanics, and how that's really working out. So you don't even need a telescope to observe the moon, but it is pretty cool to have that.
Yeah, you can watch the phases, and you can also watch the position. You know, if you were to go out at the same time each night for multiple nights, that's key, right? To keep something in any scientific experiment, you want to keep, you know, everything, as many things as you can, the same, and change only one variable, and that would be the day you're observing. So if it's the same time each night, multiple nights after each other, you'll actually start to see how it also moves through the sky. And I would suggest kind of using the background stars as a reference, right? Because then you can start to see like, wow, it moved by, you know, the width of my fist, you know, from night to night, or a little bit greater than that. And you'll, as Rob said, you'll start to get that understanding of the dynamics of how things move through the sky. And what you'll notice is that the moon is actually moving backward against the sky compared to the motion of everything else. It's moving retrograde compared to everything else, which just simply means it's moving backward. So if the sky is turning in from east, rising in the east, setting in the west, the moon does do that along with the stars on a nightly basis. But if you look at it over the course of an entire month, it's actually moving from west towards east.
Yeah. In fact, you can even see it if it's close to a planet and you look at it like right at sunset. And then you look at it again in the morning. If it's a full moon, you look at it again in the morning, you can see it's actually changed its position relative to that planet as well, which is pretty neat. Now, but here's what I see some people do, some people being me sometimes, is they go out to go look at the moon through their telescope, and they take out that big telescope and they put an eyepiece in, they aim it and they look in, and they almost go blind.
Right.
Because the moon is bright, right?
It's super bright.
Exactly. But there are, and a lot of the telescopes come with this. I have a couple tips for doing that, because also, like if you're out and you're trying to do meteor showers or something, but there's a crescent moon that you want to look at and you don't want to damage your night vision, a lot of the lens caps on these telescopes have, and a lot of people don't realize this, but they have like another cap over a circle within that lens cap. That's the point of that. You put the big lens cap on, but you take the little one off, so it allows enough light for the moon to be bright, but not blindingly bright.
Sure.
Yeah, I like that. And then I also I bought these these filters. It's actually one filter, but it's two that are attached. And what they are is they're polarized filters. So as you spin them, it lets more or less of the light through. In fact, if you have them perfectly perpendicular, none of the light gets through at all. And then you just back off a little bit, and then you can look even with high magnification, and it's not super duper bright. You're not killing your eyes as you're looking at the moon.
A variable polarizer
is
what that's called. So, and they do make dedicated moon filters as well. So they would screw onto the eyepiece and keep, once again, the light levels down. So if your telescope does not have one of those smaller holes in the dust cap, you can get a moon filter that will do effectively the same thing. Now, one of the things I want to kind of point out with the moon is that the observing time that you go out does make a difference. And I'm not just talking about night, like at what time of day, but actually what time of the month. So if you're going out on a full moon, that actually is not the best time to view it.
Agreed.
Because you're getting the light shining down into the craters, and as a result, you lose a lot of the detail, the contrast. All the shadows are gone. If you go out during the first quarter moon, or the third quarter moon, or any of the crescent phases for that matter, you have the light coming in from the side. And as a result of that, it creates shadows. And all of those craters, as a result, are put into a much higher contrast compared to the background of the bright surface. And that's when you get the best possible views of the craters. And that changes on a nightly basis. So, for example, if you're looking at the Copernicus crater one night, by the next night, it might not look as good, or it might look better. And the craters adjacent to it that didn't look as good the night before, now they look better. And so it's always, surprising to me when I look at the moon, the differences that I see from time to time. It never gets old. It really doesn't. And when you're looking at the moon, in some of the bigger craters, you can even see a central peak inside the craters, which, the amount of energy necessary to cause that to occur just blows my mind. Effectively, what's happening is you've got the impactor of, an asteroid or comet or whatever hitting the surface of the moon, many billions of years ago during what was called the heavy bombardment, which occurred because Jupiter was actually in motion in our solar system at that point in Earth's, I should say, in the solar system's history. But what was happening is this immense amount of bombardment of the moon and other planets as well. And those craters are so large that when they occurred, the fracturing of the rock actually kind of slips down and creates this central peak, which, man, it's amazing.
It's awesome
almost like
power.
Water. It's almost like a water droplet when you throw a rock into a pond, and you get that splash, that initial splash going out, but then the water kind of sloshes back in and pops out the top again. That's what it reminds me of.
Yeah. It's pretty awesome. You can also, I know there's different, I know there's like an X on the moon that you can look for. It has to be in a certain phase. And I know if it were me and I was about to learn more about the moon, I would go and look for, it doesn't even have to be a book, but get some diagrams of what little spots on the moon are and the different interesting things to look at. And no, you won't be able to see Apollo 11. You won't be able to see any of that with your telescope. So don't worry about that. That, it's just not going to happen. We have the Lunar Reconnaissance Orbiter for that. And also, if you've seen those videos of something hitting the moon and exploding, right? Yeah, that didn't happen. We would be on here talking about that for days if that ever happened. But yeah, and you can also see the smooth parts are also really cool. The Maria, where at some point in the past, lava came up from underneath and sort of laid out and laid flat. Those, and we call them Maria or oceans, even though there's no actual water, but it is the flattest part where it would be like an ocean,
marine, like a marine environment, Maria. Yep. And that's because they, initially people looked up to the moon and they saw the different coloration and they assumed incorrectly that it would be like Earth and that was an ocean on the surface, like the Sea of Tranquility, for example, where the first moon landing occurred. Next up, Dave checks out the SkyMaster Pro ED binoculars in this upcoming In Focus product spotlight. I think a combination of the 7x50s to, initially scan through the sky, and you'll have that wider field of view. And if you find something that you notice you're interested in, that's when you can jump up here to the 15x70 or the 20x80 to look more closely. But the scanning of the sky itself, these 7x50s are my favorite. I laid on my back the other night, I scanned through the sky and I looked at patches of stars. I found some satellites that I was able to actually track along with the binoculars, which is awesome. So the first thing you need to think about when you're outside under the sky is, what is it that you're wanting to look for? Now, the obvious thing in the sky, of course, right now is the moon, right? I thought it would be important to discuss how the different sizes of binocular are going to give you different views. I'm not going to be very quantitative about it. I'm going to be very qualitative. I'm going to describe things how they look to me, and it's my opinions about things, not necessarily any kind of hard facts here. But I've been doing this a very long time and I have a good understanding of what looks good. So I'll do my best to try to give you a sense of scale as well as detail. So the first ones are the 7x50s. Now the first thing to do, of course, is to get it in focus, but that's easier said than done, right? So holding my hand over the 1 for my left eye, I can get that in focus. And then I'm gonna hold my hand over my left binocular and I can change the diopter. Oh, that's smooth. So they have this thing right here, okay? You'll notice that that is the dial for the diopter, and it makes it so that this is super tactile when you're out here, that you can look at this dial and try to figure it out under dark skies with a normal binocular, or you can just feel it with this one. So I really like that. Also, don't forget that these cups do come out, and because those cups come out, and this is the same on all 3 of these SkyMaster Pro ED binoculars. First thing, once again, is to focus your left eye using the big dial, and then there's the diopter, and that diopter helps you to get the other eye in focus because your prescriptions are not identical. And by the way, if you wear glasses like I do, you do not need to wear them with your binocular unless you have an astigmatism, okay? And if you have an astigmatism, I recommend using the glasses, and these work fine. I prefer them because I do have an astigmatism. For me, I can look through my glasses in here. I can basically dial the cups down, and they do stop at different levels, and so I can get the exact level that works best for me. And once I've got that in the binocular, unless somebody else uses it, it'll just stay there. It's rock solid. I really like it. They're really nice in the hands for the ones that are the 7x50s. Another thing I want to remind you about is why you're tending to hold it here, because that's where the grips are naturally. I prefer to hold the binoculars out a little bit farther and rest them on the bridge of my nose, because it stabilizes them quite a bit more. And you can bring your arms in and towards your chest, and even hold your breath if you want to stabilize yourself a little more. But that's about the extent of it. At that point, with the 7x50s, I'm having to do that, or the 15x70s or the 20x80s, the magnification on these is so great, you absolutely want to have them on a tripod. In looking through these, the 15x70s are very interesting because from the 7x50s to the 15x70s, that extra boost in magnification allows me to see the details on the moon significantly better. Now, the drawback of having to have a tripod actually turns out to be a really nice feature because when you're looking at the moon here, any little shakes with this you are going to see. And so I had been holding on to the tripod while I was trying to use it. Bad idea, okay? Hands off. After you get it in focus, don't touch it. Try to stay just enough off of it. The other thing I had noticed that I was kind of surprised by is how the moon in a binocular, because it's a binocular, is not upside down inverted like you would see in a telescope. And so from someone who is coming from more of a telescope background, I'm used to having to explain about how the moon is flipped upside down, so I can see how for someone who is just getting started in astronomy, that could be very difficult. By having the binocular as your main observing tool for the moon, you're actually getting a good amount of detail. The brightness levels are the main thing that I see when I go over here to the 20 by 80s. Okay, so the level of the light that's coming into this one is enough that you're getting this contrastiness that you don't get with the other one. So one of the other things that I really like about the tripods is that they have, like many tripods do, the ability to hang some things off of them, and that gives them the added stability that you would desire when you have something like a big pair of binoculars at the very top of them. For now, I am just kind of hanging the 7x50s off of this in the bag, and I'm also hanging off of this one, the Ultima 80, which is a daytime spotting scope that you would use for birding or something. So I've got the 20 by 80 here, and I've got the 15 by 70 over here. And now we're looking at the part of the sky that is opposite of the moon. And so we can see there's a difference, but unfortunately at the farm, this is in the direction of the most city lights. So I do have a dome if you can see it there probably, a dome of city lights from my local town. This direction tends to be the most clear, and that's where the moon is right now. Looking up here, I can find some pretty bright stars, and you might want to use this to look at the different colors of the different stars. There are star clusters, such as globular clusters, that you might want to look at. There are open clusters of stars that you might want to look at. The stellar objects are usually pretty easily seen in binoculars because they're pinpoints of light. Some nebulae are visible, but it becomes more difficult because the actual photons are spread out as opposed to being like a star is where they're all concentrated. So be careful when you're looking at the magnitude scale of nebulae. And the same thing can go for galaxies. Some of them are visible in the binocular. They're sufficiently bright. Their surface brightness across the entire galaxy is very large, but there are many of them that you won't see. With either of these, I don't actually like to look for these objects with these types of binoculars right away. Here's where having the different ones is kind of like when you have different eyepieces. I actually don't like just starting with either of these two pairs of binoculars. I think a combination of the 7x50s to initially scan through the sky, and you'll have that wider field of view. And if you find something that you notice you're interested in, that's when you can jump up here to the 15 by 70 or the 20 by 80 to look more closely. But the scanning of the sky itself, these 7x50s are my favorite. I laid on my back the other night, I scanned through the sky, and I looked at patches of stars. I found some satellites that I was able to actually track along with the binoculars, which is awesome. You're not going to see detail on those objects, but the International Space Station, you might have a chance. The smaller satellites, not so much. I am looking at Antares right now with the 7x50s, and the color of this star, this orangish color, is so different from all of the other stars that are around it. The temperature of the star is why it's the different colors. So that's actually indicating that Antares is cooler than the surrounding more blue colored stars or white colored stars. The other one that is out right now is actually right up above me there in that direction, and that is the Big Dipper asterism, and it goes the arc to Arcturus. And if I'm looking at that one, again, I'm getting that very different hue, that different color that you would have seen compared to the other stars in the sky. Very distinct. I can also pinpoint some doubles. So some doubles to look at would be like Mizar and Alcor in the handle of the Big Dipper. It's kind of cool. You can split the
Mizar and Alcor with your eyes, but here in the binoculars, it's just so much better. It's such a great little double. And you'll notice that upon zooming in, that it's actually not just one set of stars, it's two sets of stars, or four total. Two binary systems sitting right next to one another. In fact, I believe one of those is a spectroscopic binary, where one of those stars is not visibly able to be seen as different, but through spectroscopy, we can detect that there is a second star that's orbiting very, very closely to the other one. So that's spectroscopic binary, not visible even through telescopes. I like both of them, all right? That's definitely the case. In fact, I like all three of them. It's just that they have different uses. So what else could we be using these for? Well, tonight we've got the moon shining very bright, and so I'm finding it difficult to look at anything else. Even through the telescope, it is kind of a problem to have the moon in the sky like this. So what I'm planning to do is going to bed, and then later on tonight getting up once the moon has set, and that way I can observe when it's darker outside, because not of the actual amount of sunlight, but it's the moonlight that we're contesting with. So I'm gonna wait a few hours. It moves approximately one width of your fist every hour. It's about 13 degrees. Your fist is approximately 10. So here we go. We've got 1 hour, 2 hours, 3 hours, and it's gonna be over there in the woods. Another half an hour or so, it'll be below the horizon, and our skies are gonna get significantly darker. Now, if you're dealing with light polluted skies, do your best to get portable, and what better way to do that than using binoculars, right? So I can throw this back into my car. In fact, both of these tripods also come with cases. Each of these, they come with their own case. So we've got the one here for the small 7x50s. The binoculars fit right in, and this makes for a really nice portable way. You've got this and your tripod if you've got one of the bigger ones. And the bags are super durable, keeps everything in place. Don't forget, if you're getting the 7x50s or the 15x70s, that you're going to need to get the tripod adapter, whereas the 20x80 comes with the tripod adapter built into it. So you don't need it for that one. But that's such a great way to get portable and get out to those clear, dark skies. Thanks a lot, and keep looking up.
The moon's great. What about those wanderers, though, right? We've got those naked eye planets, which we talked about in the trivia. We've got Mercury, Venus, Mars, Jupiter, and Saturn. Now, with the naked eye, these are still really cool to see with the naked eye. The telescope's even better. But with the naked eye, Venus is super duper bright. Venus is typically either it's either an evening star or a morning star. Because if you think about it, in our orbit, the Earth is on the outside, Venus is on the inside track, so it's going to be close to the sun. Same thing with Mercury, but Mercury is dimmer, and it spends its time closer to the sun. So that's also a sunrise and sunset planet, and it's usually closer to the sun. So it's typically harder to find, and it's a little bit dimmer. But I really like Venus because of its brightness. And if you do have a telescope, you can see it go through its crescent, half, and gibbous phases as well, which is really neat. Mercury, not quite as cool, but I love the fact that I can catch it if I have a really good view of the horizon and I'm looking at the right time, right?
Yep. Now,
go ahead.
One of the things that I know that you like, because I've seen pictures of it, and I, for many years, just driving into work, would catch myself maybe looking up at the sky while I should be mostly driving, is when you have a conjunction.
Yes.
Right? When you have the moon and a planet, or maybe two planets, or more than that, all together into very close proximity to one another in the sky. And over the course of the last few years, we've had a number of really, really good conjunctions And I was fortunate enough to go out and view some of them, especially when you get a very thin crescent moon and Venus. It looks magical almost. Like it looks like something you would see in like a movie. It catches people's attention that aren't normally looking up. So if you've ever seen that, if you've ever noticed, the moon and a bright star-like object in the sky, you probably have seen a conjunction. And now, while I say the word star-like, one thing to consider is how would you know if you're looking at a planet naked eye?
So
Rob?
What I've heard, and I can say this is kind of true, is that the planets don't twinkle.
Right, stars twinkle and planets don't. Right, Twinkle Twinkle Little Star is due to a atmospheric effect called scintillation. Right, so we've got the like on a hot summer day, you would see the what would be like heat waves off of asphalt. Right, the refractive index of the actual air, the way the light passes through the air, has almost a lens-like property. And when you have differences in temperature, you can bend the light in different ways. And so stars, their light is coming from a point source that's very, very far away. And as that light's passing through the atmosphere, the atmospheric turbulence causes the light to shift back and forth, just like that heat wave effect you're seeing on that hot summer day on the asphalt. Now, because it's coming from a single point source, you're getting a stream of photons from one spot in the sky. Even if we look at it through a telescope, even the Hubble Space Telescope, you're still seeing a single point of light. The planets, however, they have a width to them, an angular size. And as a result of that, it does not show up as much. That scintillation effect, that twinkling effect, doesn't appear as great as it would for a star because of that width, right? There's not a stream of photons coming in at one spot. It's got some width to it, and that kind of cancels out some of that effect. So stars twinkle and planets don't.
Excellent. Yes, you are correct. I kind of think of it as the planets are a little more, they're not quite as pinpoint to me, and they just sort of, they just look a little duller, if you will, comparatively. I also find that the planets are typically brighter than the surrounding stars. It's pretty typical that they're brighter than all the stars around it. I said that Mercury and Venus, the strategy is morning or evening, no later than I think 2 hours before or after the sun sets or rises. But with Jupiter and Saturn and Mars, they're usually up there in a position in the sky, and they're up there and slowly moving across the sky over like a 6-month time period. So the thing is that usually with Venus or Mercury, you kind of got to get out at like a certain day or week, whereas or month. We've had a time where Venus was out for like 9 months in a row around sunset. But the bigger planets, Jupiter, Saturn, and also Mars, they tend to stay in a part of a constellation. It travels through it, but it stays kind of in the same area for the most part. And constellations are up there for about 9 months total, depending on the time of day that you're looking. So you kind of get a little more wiggle room with the outer planets than you do with the inner planets.
So the reason why you're seeing Venus and Mercury near the sun, think about it, their orbits are inside of the orbit of Earth's orbit. And so they have to be closer to the sun in the sky at all times. Whereas the outer planets beyond our Earth's orbit, which does include Mars as well, all of their orbits are superior. They're beyond Earth's orbit, and as a result, they will appear to move through the night sky, as Rob was saying, through the constellations of the zodiac, right? And so the zodiac constellations, there are actually 13 of them. Ophiuchus is oftentimes left out. But those zodiac constellations, the importance of them, from like an astronomy standpoint, is that that's where the sun and the planets and the moon all pass through. And so when we're talking about a planet being within a constellation, what we mean is that from our perspective here on Earth, that when we look towards that planet, we're seeing a constellation in the background. And that changes as that planet moves throughout its orbit. And some of the orbits for these outer planets take many, many times longer than an Earth year. And so they don't appear to move as much as you go farther and farther and farther out. In fact, some of the planets, as we go farther out, are like an entire human lifespan. And so you're talking about orbits now that take, 80 years or something, right, to occur as we go out to like Neptune and beyond. And, as a result, they won't move as much as the ones that are closer.
Let's say I want to actually look at one of these planets through a telescope. Now, what I've heard is that refractors are better for looking at planets. All right, so let's say I actually want to get a close-up view, right? Like I want to see Saturn's rings. I want to see the moons of Jupiter. I want to see Venus's phases. Now, I've heard that refractors, right, the telescopes with the lenses on the front, are better for planets, whereas the reflectors, the mirrored ones that you can get bigger apertures for cheaper, are good for the deep sky objects. But I remember you telling me that that's not necessarily true. Can you tell me a little bit more about that? Because I have looked through refractors at Saturn, and it's pretty nice.
It really depends, right? So there are benefits and drawbacks to all of the different telescopes designs, and that's why there are so many different telescope designs. Now, refractors, the ones that have lenses without mirrors, those are the ones that a lot of people think of when they think of a telescope, right? They're the ones that Galileo was using. And if you ask somebody to draw a telescope, that's what they're gonna draw.
Or you ask AI to draw me a telescope, they're gonna give you that kind of stuff.
Exactly. Now, they can be very good for planets, but if they are not well corrected, and what I mean by well corrected is that they have optics that are very basic, they can introduce color fringing, chromatic aberration, where you'll see kind of a rainbowy effect. So the planets, because they're bright, have a tendency of kind of exacerbating that. So when you're looking through a refractor at a planet, if you see anything like that, that's possibly what you're observing. Now, reflectors don't have that effect, but they also can suffer from some other types of things that are other aberrations, like spherical aberration. And when you're looking at a planet, the detail that you can get with a refractor is more difficult to achieve with the reflector, but you don't get any effect of chromatic aberration now, which, as we discussed in a previous episode, that was kind of the whole point of Isaac Newton's design of the first reflector, is to get rid of that problem of chromatic aberration. And so the reality is that any of these telescopes are good for observing, and it really depends on a lot of factors that it's very difficult to say. And I think everybody wants their own telescope to be the best, right? There's lots of different apps out there that you can use and pull up, what these objects will look like.
Yeah, I have never really lucked out with looking at Mars. Now, that's probably more due to me not being very well. But when I have looked at Mars through a telescope, it was not during opposition, and it was kind of disappointing because it was just a little red dot.
Right.
Now, luckily, I just looked it up. It looks like we have the next opposition of Mars is January 16th of 2025.
Okay.
So if you've got a telescope and you want to start looking at Mars, start getting ready, start getting used to using that telescope. And then January is going to be a real good time to check out Mars?
I think even better than that is, as soon as Mars is visible, start viewing it now, right? View it as it's coming towards us, and you'll start to see the change in angular size. It'll get bigger and bigger and bigger and bigger and bigger, bigger and bigger. Then it'll get to opposition, and then it'll get smaller and smaller and smaller and smaller, right? So these actually coordinate very closely, by the way, with the launch windows to Mars if we're trying to ever go there with a Mars mission, because you're going to try to launch right before it gets to opposition, let it kind of play catch up with the Earth, and then you get your spacecraft there around that same time. So this kind of opposition thing is going to be coinciding with possibly future Mars missions. And I cannot wait. I hope I see it in my lifetime when I can look at Mars and know that there is someone out there walking on it. That's going to be cool. So
that is going to be cool.
Will we see them? No. But
no, not at
will
all.
It be pretty cool to know that I have them within the view of my my field of view of the telescope? Yes.
Just like whenever the ISS goes over, I go, man, there's 6 people just flying right over me right now. Like, that's a cool feeling.
Right, we're going back to the moon, and that's going to be a similar experience. I know, of course, some people have had that experience, that are a little older than us. But that's something that I've always wanted to be able to experience, is knowing that I'm looking at the moon and that somebody's out there right now walking on it. That'd be so awesome. Yeah. And that's going to be happening again very shortly.
Hopefully. So let's move to the other 2 planets that are really cool to see, Jupiter and Saturn. So these are, again, outside of Earth's orbit. So they stay generally inside a constellation pretty much. Now, Jupiter, my biggest things are usually the moons, which you can see in any telescope. You can see in a pair of binoculars. You can see in one of those, do-it-yourself telescopes. If you have it steady enough, you can see the 4 Galilean moons. Quick quiz. What are the 4 Galilean moons? Go.
Io, Callisto, Europa, and Ganymede.
Ooh, you're quick. Nicely done. I always miss one of them, and it's never the same one. It's always a different one every single time. But yeah, so those were the 4 moons that Galileo saw with his first telescope. And I think there are some rumors that some people, I think in ancient China, could actually see the moons of Jupiter with their naked eye, like they held a piece of grass up or something. I don't know. I might just be remembering some weird stuff, but all you need is a pair of binoculars. Make it nice and steady, and you can see those. And the cool thing too is that they move throughout the night. So if you go out in the beginning of the night and then you go out early in the morning, you can actually see how they've shifted, which is pretty cool.
Right. And if you're out at just the right time, once again, I would suggest using one of the apps out there to try to find out when these things will occur. You can have transits where the moons will actually pass in front of Jupiter. And if you know what to look for and where to look, you can even see the shadow of the moon being cast onto the surface of the planet. That's pretty amazing to see. I've seen it a few times. And also we have occultations when it's passing behind Jupiter as well. And that's something that is pretty neat, especially if you're watching as it becomes occulted when the actual event occurs, because it'll just kind of like fade out and be gone.
And you're basically seeing an eclipse of Jovian moons, right? Like that's pretty cool. You're seeing when the transit goes and the shadows going across Jupiter, you're seeing what a total solar eclipse looks like on Jupiter, which is just really cool. And then of course, Jupiter has those cloud bands, right? Little stripes, essentially.
Zones and belts.
What's that?
They're called zones and belts. And
zones and belts.
Yep. And the ones that are kind of the brighter ones, they're actually at a higher altitude in the atmosphere, and the ones that are darker are actually deeper into the atmosphere. So if you are observing that and you're looking at those stripe patterns, you can actually imagine now the 3-dimensional aspects of that as well, which I always thought was pretty cool.
Yeah. And it's got that great red spot, right?
Yep.
Which is like 3 Earths big. And it disappeared for a couple years in the past, right? And then it somehow reappeared.
It started to get smaller. I wouldn't say it disappeared. It definitely got smaller, okay. and there's still some debate as to what exactly is happening. But it's been there for a very long time. I mean, as far as we know, it was visible even as far back as Galileo's time.
Yeah.
So we don't know how long it has been there. It's effectively like cyclonic activity, and as a result, we're seeing a storm system effectively.
Right.
It's been lasting for hundreds of years.
Come on, that's amazing, right? Like,
with the gas giants, the kind of interesting thing is that the ability to monitor and track the activity in the atmosphere is actually easier than Earth, because it doesn't have all of the disruption of surface features that Earth has, like continents and water bodies, and all of that variation in the terrain can affect, your atmospheric conditions, and as a result, weather patterns. There's none of that on Jupiter, and so it's basically all very laminar flow. It flows fairly easily across the underlying layers of the planet, and so that plays a role, of course, in the ability to have one of those storm systems be active for that long.
I never thought about it that way, actually. It makes a lot of sense that you don't have that interaction between water and land and all the topographical features. And lastly, we've got Saturn, which with, again, any telescope, you can see the rings. Now, if you have a different telescope, you might be able to pick up more of the rings, or at least it'll be bigger. But the rings of Saturn, this is the classic, just aha moment for a person in astronomy. They
Absolutely.
see Saturn's rings and they go, wow.
Yep.
Right? And it's just a whole bunch of debris that's just all going around the planet. They're not solid, right? You can actually go right through it, kind of like Wall-E did, right? And Saturn is really, really cool. One of the things you want to be careful of when you're looking at Saturn, because I've done this a bunch of times, is don't try to bring the magnification up too much, because when you bring the magnification up too much, it gets bigger, but you're dealing with the same amount of light, so it gets a lot dimmer, and so you can't really see as much detail. It kind of seems counterintuitive, but you kind of want to balance between it. You don't want it too small that you can't see any detail, but you don't want it too big where it's too dim anymore.
Right.
What have you encountered in terms of looking at Saturn?
One of the things that I enjoy looking at are the gaps in the rings, the divisions. The most famous, of course, the Cassini division. And the reason for these divisions actually has to do with the moons and moonlets that are within the ring system. And there's these gravitational tidal effects, they're called, where basically the moons will clear a path around in that part of Saturn's rings. The gaps are actually a result of that gravitational effect.
If you're new to astronomy, I would say your top targets are Jupiter and Saturn and Venus, with Mars and Mercury also in there. And just one last tip is you're not going to be able to do it with Venus and Mercury, but with Jupiter, Saturn, and Mars, you're going to get better results if they're higher up in the sky. They don't need to be way up above you, but you don't want them way down on the horizon, because again, you get that scintillation that Dave was talking about, and you usually get even darker skies when they're up a little bit higher. So make sure you're, just at least higher than like 15, 20 degrees, and you should be just fine. We're going to take a little break right here and come back with a second round of trivia.
Rob turns up the heat on Dave in this next round of Last Minute Trivia.
Unlock the power of your smartphone to help you navigate the sky with Celestron StarSense Explorer. The telescope works with your phone using patented sky recognition technology to pinpoint its exact position in the night sky. Select an object to view and follow the on-screen arrows. The bullseye turns green when your object is visible in the eyepiece. It's astronomy made simple. Learn more at celestron.com/explore.
All right, Dave, second round of trivia. Are you ready?
Yes, as ready as I'm going to be.
All right, fantastic. Now, the first question is going to be a little bit more of a feeler. See if you know this. Above what aperture do reflectors and refractors start becoming drastically different in price per inch? Is it going to be A, 2 inches, B, 3 inches, C, 4 inches, or D, 6 inches? Now, we all know, while you're thinking, we all know that reflectors, the ones with the mirrors, you can make them a lot bigger for a lot cheaper, right? Whereas the refractors that have the lenses, as they get bigger, it's harder and harder to actually get good optics at a good price. So when does that big split really, when do the refractors really go up in price?
So what were my options again?
2 inches, 3 inches, 4 inches, or 6 inches?
Definitely 6 inches.
It is, well, definitely 6 inches, yes. I'm going to give you half a point because I'm going to say that C, 4 inches is when they actually start getting a lot higher.
Sure.
So, I'll give you half a point on that one. In fact, I looked it up. Basically, a reflector at 4 inches is around $400 or so. But you can find some refractors that are higher than that, and then there are some that are way higher than that are also at 4 inches. But yeah, definitely 6 inches. A Dobsonian at 6 inches might be $700, and there's lots of variability in there. But some of the refractors at 6 inches are like $1,900. So you're talking a big jump in that price. So, choose wisely. Now, we've got a second question here. And what are some ways to upcycle your old, unusable telescope? And I'm going to give you 5 options. You tell me if you can do this.
Okay.
A, decoration around the home. B, a lampshade. C, a DIY vintage movie camera. D, a can jam target. Or E, a potato gun. Or secret answer, F, all of the above.
F, all of the above. I don't know.
I'd go with F, all of the above. I was looking for some examples, and of course, everybody can put one as a decoration, but I saw somebody actually take a refractor and take out the lens and put a light bulb in there and make it like a lampshade, which looked kind of weird, but it worked. And yeah, somebody took like I don't know if it was a lens cap or the dew cap, kind of chopped them off and made like one of those old school 2-circle movie camera, like reel-to-reel camera things. I saw that. And I just invented the can jam target. I just invented that up. I figure you could probably throw a Frisbee in a big enough one, as well as a potato gun. I feel like there's some physics teachers out there who would enjoy making a potato gun. Last question. What object is most often mistaken for a, quote, UFO? And I'm going to have you just guess without options.
I would say that would be Venus.
Yes, that's the one that's most often cited as the most common one. And it makes sense, right? It's bright, it's low on the horizon, it's sort of setting and it'll disappear like an hour or two later. Now, the next part of the trivia is, how many of the other ones do you think you can name?
Other
things
what?
that are often mistaken for some sort of flying saucer or alien spaceship.
Celestial objects?
Yeah, or regular objects. What do people usually call in as UFOs? What do you think?
Airplanes?
Yes.
Satellites?
Yes.
And meteors for meteor showers.
Yeah. So I looked at a couple lists online, and I found Sirius is sometimes identified, brightest star in the sky. Jupiter, similar brightness to Venus, right? Rocket launches. We saw one coming back from Cherry Springs, right?
Yes, absolutely.
And we were looking at it like
the SpaceX launch. It was the wildest thing I've ever seen in the night sky, and I was completely taken up because especially where we were nearly up at Cherry Springs State Park. I mean, we were well up in the mountains, deep in the heart of like the Susquehannock State Park. I mean, it was crazy, and we were on our way home. Did not expect to see that from there.
Yeah, especially now they launch right around dawn or dusk, and they have these huge plumes that you can see. So I can see why people would see that. Comets, military jets, weather balloons, meteors, fireballs. Oh, this one is my favorite. Lenticular clouds. You know, the type of cloud that like forms over a tall mountain like Mount Fiji, and they kind of look like lenses.
Yep.
Of course that's going to be mistaken for a UFO.
Sure.
And the last one is, well, everything is a UFO if you're bad enough at looking at things. Next up here, I have, as far as things that people want to see in the night sky, is globular clusters. Now, I know that with our naked eye, we can probably see a couple. I think I've seen the Hercules cluster with my naked eye. I was in a very dark sky site, and it was very good seeing. And I just barely made out that faint fuzzy up there. But can you tell us a little bit more about what a globular cluster is, and then how do we actually find them in a telescope?
So a globular cluster is a grouping of, many tens of thousands of stars. And we don't actually know how they formed. We know that they're very old. And the question is, were they formed as their own separate objects and were basically collected by the galaxies as the universe, was being born? Or are they actually part of the process of galaxy formation? What we do know is that it appears that galaxies all have globular clusters. If we look out at other galaxies, we can see them. For example, Andromeda Galaxy has globular clusters as well. And there are many of them, over 100, that are in a spherical pattern around the entire galaxy. So they don't necessarily follow the normal disk shape. They're in what's called the halo. And so we, once again, don't know exactly how they formed, but we do know that they're old. And the reason we know that they're old is because they've got only stars that are more like the older, redder type of stars. When stars are very large, they produce a lot more energy, and as a result have the ability to be more on the blue side of the spectrum. And those are the ones that would form like things like supernovas later in their lives. And their life cycles are very fast, and they use up a lot of gas in that process. And the globular clusters are almost completely devoid of gas. They've used it all up. And so all that's left are these smaller stars that continue to be, in that first stage, that first life cycle. And we can actually use that as a way to date how old the globular cluster is.
So then when we're looking at these things, what do they look like when we're looking at them in the sky?
Basically what you'll see is it looks like an enormous patch of stars all clumped together. The central point of them, it can be so close together that you cannot actually differentiate the individual stars. It just looks like one big solid lump. And then depending on the size of telescope that you have, you basically see a kind of like a gradient of less and less and less stars as it gets farther and farther from the core. I've had an opportunity to look through an enormous Dobsonian. I think it was like a 24 inch, something like that. And I mean a 36 inch I've seen a globular cluster M13, the Hercules cluster with, and the amount of stars that you're able to take in one eyepiece is just unbelievable. And so they all kind of look the same. There are some slight differences if you know what you're looking for. And they are generally seen, in the same season that you'll be seeing like galaxies, which would be, the late March, mid-May time frame when it's galaxy season, because you're able to see farther out. But they are, in fact, around all throughout the year.
Okay. So then it sounds like if you're going to get a telescope to see globular clusters, you're going to want to get a light bucket. You're going to want to get a reflector that can take in a lot of light. Is that correct? Or are there still advantages with a refractor?
Because they're stellar objects, that they're made of stars, the pinpoints of those stars are relatively bright, and you can get away with pretty much any telescope to look at a globular cluster. However, your ability to resolve different stars that are kind of close to one another, it improves as the size of the telescope gets bigger, and there's no way to get around that physics. Because it's one of the properties of telescopes is its resolving power, and the only thing that really truly controls that is the size of the aperture. So the bigger the aperture, the more resolving power you get, which is the ability to separate 2-point sources of light from one another at smaller and smaller scales.
Okay. All right. Now, I've noticed when I try to go out and look for globulars, one of the important things is to make sure that the moon is not out, right? Or at least not a half moon or bigger, because you get too much light pollution. You can't really pull out as many stars. Have you found the same thing?
Sure. I mean, it certainly makes it more difficult to have contrast in the sky when you have a full moon out there, for sure.
Okay. All right. So we've got globulars out there, and you're going to need more of a telescope to see the globulars. One of the popular things that I found to find, and one of the first things I find when I do get a new telescope, is a nebula, right? And of course, the most famous one is the Orion Nebula, right?
Yep.
It's a very famous target for, the first time you take out a telescope. You kind of remember what it looks like because you've looked at it a lot. Actually, first of all, am I correct in saying that you can't see any nebulae with your naked eye?
Oh, you can.
Really?
In fact, one of them that you just mentioned there, the Orion Nebula, is visible from a dark sky site. So, when I go up to Cherry Springs, you can just look right up in the sky and you can see it.
Okay. It's got to be pretty small, though, right? Pretty hard to see?
It's bigger than you'd think.
Okay.
It's pretty impressive. And you can make out some other ones if you know what you're looking for. Trifid and Lagoon Nebula, kind of look like little smudges.
Okay.
They're relatively bright. They're relatively large in terms of the angular size. And if you're in dark enough skies, you can definitely see it.
Okay. All right. So you're going to have to hunt for it, but it is there and you can see some with your naked eye. So what if I want to see it better? Are you thinking a bigger telescope or a certain type of telescope?
Certainly the bigger the telescope's aperture is, the more light you're collecting, the easier you'll have a chance to see it. But it is important to try to get to darker skies. I think that's the biggest difference, because these are not stellar objects. They're not pinpoints of light. They're diffuse. And as a result, because their light is spread out over a larger area, it's more difficult to separate that from, the background of light pollution.
Right.
And of course, going out during a new moon is always recommended when the moon is not visible in the night sky.
Because really, you're talking about with a nebula is typically just a big area of gas and dust that's reflecting light off of other stars that are nearby for the most part. So it's kind of like a light in a fog machine at a dance or whatever. So it's going to be dim. So you want to be able to collect as much light as you possibly can.
Right. And so there's actually 3 different types of nebula, to clarify. There's an emission nebula. Emission nebulae are basically being heated up. So that this is gas that's being turned hot due to its proximity to stars. And as a result of it being heated up, the atoms within the nebula become excited and they emit a particular color of light. So that color for hydrogen would be like a pinkish color. There's also reflection nebulae, And reflection nebulae are, as their name implies, reflecting light off of them, and they tend to be more blue in color. Then the last of them is the dark nebulae, and dark nebulae are more dense, cloudy type things that are kind of in front of the light source and blocking and silhouetting the actual nebula itself. And most times you're going to end up with a mixture of all three types. In these complex areas of the Milky Way especially, you're going to end up with all three types in close proximity to one another, because in reality, you're looking at a three-dimensional object. And so once you start to kind of think about that, it's one of the things I always like to do when I'm observing, is to realize that this is not a single object. This is a bunch of gas, and you can actually start to make out like, oh wow, I'm looking in towards, where that star is at. And for example, the Orion Nebula, there's some core stars down in the very heart of the Orion Nebula that you can't even see, but you can kind of see this light spilling out from inside the nebulae, because the actual stellar winds and the radiation pressure of those very large stars are actually blowing a hole in the nebulae, which is why you're seeing them,
Right.
And they're kind of shrouded out by these dark nebulae, like Horsehead, for example, is a great example of that. It just gives you another way to kind of enjoy these objects. And as you observe them more and more, you become more familiar with them, and they become kind of like old friends. You can go back to them each year and you can kind of study them further.
In fact, one of the old friends that I'd like to visit every fall and winter is this little patch of the sky that is a little difficult to sort of guide my way through. There's a couple guide points, but it's this faint smudge in the sky called the Andromeda Galaxy.
Yes.
Right? It's, now you'll see pictures of this online. You're not going to see what is on a picture online if you're looking through a scope, right? But I have seen in my skies here in Pennsylvania in the yellow area on a very clear night, you can actually detect a faint little smudge up by Andromeda near Pegasus, near Cassiopeia. You can actually see a little smudge. I've seen it. It was easily found when I went up to Cherry Springs.
Yes.
Because it's very dark, so there's more contrast. Like you can't, the rest of the sky is black, so it's easier to see. If I'm going to look at the Andromeda Galaxy, I need to get my 10-inch Dobsonian or something like that, because I want to bring in as much light as possible, right?
Sure. Yeah, aperture with any deep sky object is something, if you're doing visual observation especially, is very important. And the Dobsonian is in one of the best ways to kind of achieve that on a budget. Is, it's a light bucket, as you said.
Yeah. I love looking at Andromeda because it's actually kind of deceptive. Like it only looks, when you look up there, it looks pretty small. It's quite large.
Yeah, it's huge. 3 degrees in the sky. It's about 6 full moon widths across the entirety of Andromeda Galaxy. It's that big.
6. That's big.
It's enormous.
It's huge.
It's about 3 fingers wide at arm's length. So some real quick, measurements. You've got your pinky is approximately at arm's length, hold it out as far as you can, is about 1 degree. So the moon and sun are about half of your pinky's width, which seems small, but try it. Next time you see the moon in the sky. 5 degrees is effectively what? The 3
fingers.
3 fingers wide. And then the fist, right? About
The width of your fist.
10 degrees or so. And then we've got
Rock on, man.
rock on is about 15. And, you can always put 2 hands together and get to 30, which these measurements are rough, but they actually help quite a bit. So if you're looking for, a particular object in the sky, you can always use your hand as a measurement tool.
Or if you listen to that other podcast about astronomy, Last Minute Astronomer, and he talks about, it's 10 degrees above the horizon, hey, that's 1 fist width. I put the bottom of my fist on the horizon. Mercury will be about 1 fist width above that. Yeah, it is actually quite handy. And it's, I like to look at, it's what, 2.5 million light years away.
Mm-hmm.
And so this is the cool part of astronomy, which we've talked about before, which is you're seeing 2.5 million years into the past, right? Because that light traveling at light speed took 2.5 million years to get to your eyeball. And those photons were sent 2.5 million years ago, 2.5 million light years away, and it landed on your eye. Like, that's really cool. Dave, we are kind of wrapping this up. We've talked about basically everything that you can see with a telescope out there. You know, we just talked about galaxies. We talked about the globular clusters, which are neat to see. And of course, the planets, the Milky Way and the moon. As we wrap up, what do you think? What's your favorite one to take a look at?
Well, we haven't discussed some of these other objects like supernovas and planetary nebulae. And for me, I find them fascinating because what you're observing is the end state of a star's life. And although they're called planetary nebulae, a planetary nebulae is the death of a sun-like star. And so within that planetary nebulae is what's called a white dwarf. And at the end of our sun's life, which we're about halfway through our sun's lifespan, which is about a total of 10 billion years. We're about 5 billion years into that 10 billion year long lifespan. And what basically occurs is that it's used up all of its fuel, and that fuel is hydrogen gas, mostly turning into helium. And they kind of fizzle out, and the gravitational effects are no longer able to hang on to the material as the core of the star starts to produce some additional elements, which we're not going to get into the details of today. But basically it blows. Yeah, that's a completely separate podcast.
Yep.
But it blows those outer layers away, and you end up seeing this remnant called a white dwarf. The other type of object that can be produced by larger stars is a supernova. Now, supernovas come in many types. Once again, we're not going to get into great detail here, but in the center of a supernova can be one of two objects. One of them is a neutron star, and the other one is a black hole. And that all depends on the amount of mass that remains at the death of the star. So, of course, the black hole being the larger of the two. Now, I look at these objects not as their own separate thing, though. My favorite thing to talk about and to view myself is the full process of what's called stellar evolution. And so when you're looking at a nebula, you're seeing a stellar nursery. You're seeing the stars being born. When you then look at something called an open cluster, which is not a globular cluster, it's an open cluster, that's when you basically have a bunch of stars that were born together in a nebula, and the gas from the nebula has been blown away by the stellar radiation, and you're left with a patch of stars that move through the galaxy, because keep in mind, stars do move around the galaxy.
Yep.
And over time, they will spread out, but you're seeing in an open cluster an early state of those basically, juvenile stars that have just kind of exited the stellar nursery. They no longer have the gas around them, but they're still in their grouping. And we call those associations. As they start to spread around, we can keep track of them by how they appear to be moving throughout the galaxy. But then, as we start to see the stars die, we'll start to observe these different types of stars and the different types of stellar remnants, the planetary nebulae and the supernova remnants. And then that whole process starts over again.
Right.
This is a cycle. And for me, I really like to think about that a lot, because as these supernovas are occurring, they are producing the elements necessary for life. And we are living in a solar system on a planet with heavy metals that were produced in supernovas. And some of those metals and other materials are flowing through my body right now. The heart of these largest types of stars, the red supergiant stars, they produce iron. Iron is a necessary component of your blood to be able to transport oxygen. And so you're seeing basically yourself. You're seeing our own making in these objects. And we're living in a star that, had other stars that came before it that made it possible for us to be here. Yeah. And as Carl Sagan says, we are all made of stardust, right? And for me, that really hits home.
Yeah. I can't think of anything more metal than a supernova explosion spreading its guts across the galaxy,
right?
And then a new solar system using that, and the leftover detritus of that stellar formation then breeds life out of the ashes of that supernova. Come on, how cool is that, right?
Yep. And supernovas actually, they can actually trigger other activity, other new star formation through the swirling of dust and gas within the nebulae. So, this process of stellar evolution to me is what I look for when I look up at the night sky, and I try to impart that, same perspective to others. So let's wrap up here. Just talk about briefly the ways to share astronomy with others. You and I have been in a local astronomy club, and we've talked about in previous podcasts how important those local astronomy clubs are. But one of my favorite activities that we were able to do with this club is to kind of bring the public out to use telescopes and look through our telescopes and share it with, people of all ages, and just feel their reactions. It's amazing to witness the first time somebody looks through a telescope, and
it is something special. And that's why whenever I do star parties and such, I have these little certificates, right, that say, hey, star party name, you write down their name, and then you say, hey, what did you see? And they're like, oh, we saw Saturn. Was that the first time? Yeah, it was. And so you say, I saw Saturn for the first time. And then they have this little thing where it goes, this is the first time I saw another planet close up. I love doing that because it kind of puts that seed in their head, and then they have that, whether they put it on their wall or just stash it under their bed, they do have it, and they might come into contact with it again in the future and go, oh, I remember that. That was awesome. I want to do that again, right? So I love doing that certificate thing. It's very, very simple, but I think it's pretty effective. And I also, like you said, I rely on our local club to bring out their telescopes, and I rely on experts and friends to come out. And I think that's also one of the cool parts is not only do you have other people helping other people, you're building a community in that sense. Or if you're out looking in your backyard and your neighbor sort of walks out, is walking his dog, and you say, hey, I've got Jupiter in the scope. You want to take a look at it? You're building community and you're building relationships. I think that's really a valuable part of this.
Absolutely. It's one of my favorite things, as I said, especially for little ones, to have their chance to see, just the reaction on their face when they look through the telescope for the first time, for sure.
And I know we've been kind of telescope centric here tonight, but I do want to mention, I don't want to get into it, but I do want to mention that finding constellations and asterisms is a really easy way to get to do this. There's lots of good sky maps out there that will tell you what constellations are where and when, and they put them out monthly. And You know, even if you're at a beach town, like sometimes I go to Ocean City, Maryland, or Wildwood, and it is lights galore over there. However, I can still see the summer triangle, right? Cygnus, Aquila, and Lyra, and their brightest stars, Deneb, Altair, and Vega. I got it. Yes. You know, you can still see those even in the very light polluted skies. And I would highly recommend just get a constellation book or just look up a sky map and use that, hopefully with a red light and not, you know, your phone, and just go out and see if you can find the constellations. You don't need a telescope. It certainly helps and is a lot of fun, but I'd say just go out, get some constellations, and go ahead and make your own constellations. They're all arbitrary anyway. Make up your own. It's more fun.
I do want to highlight that our sponsor, Celestron, has offered a $100 gift card for their threadless merch store. And Rob and I are both wearing our Cosmos Safari podcast shirts today. And
Indeed.
I've got my Cosmos Safari podcast mug here. And I'd
It
love
holds liquids very well. 100% guaranteed it'll hold your liquids.
And all you got to do is find over on Celestron's Instagram the details about this particular drawing, and they're offering the $100 gift card. The details are right there, so check it out over there on Instagram, and you might be the lucky winner to get your Cosmos Safari gear. And for the rest of you, the store is open.
Yeah, I love seeing this stuff all over the place. I love talking to people around the world, and you know, building this community as we go is really something special. So if you can help out with that, that would be fantastic.
I am thrilled to finally have a chance to talk about some of these objects that we all enjoy. And there's more to come as we continue on with the podcast. We've got some great guests coming up. So if you haven't already, hit that subscribe button. And thanks for listening or watching.
Clear skies to everybody.
Clear skies. If you're still listening and like this podcast, please consider becoming one of our Patreon patrons. Memberships start as low as $3 per month, with benefits including opportunities to ask questions of our guests. Also, please consider liking, subscribing, and sharing this podcast to help us bring the universe even closer than you think. The podcast will be available every third Tuesday of the month.